Hello, ladies and gentlemen. Thank you for joining me once again. We're looking now at question number 6 on the 2012 MMC, or Manitoba Math Contest. Okay, put out by those wonderful folks at the University of Manitoba. Question 6 says, to represent a number in a base system other than 10, say base b, where b is greater than 0, we write s with a little b here, where s is a string of suitable digits in base b. So these numbers can only be from 0 up to b minus 1. If this is your first introduction to bases, you might have done a little poorly on this question, and that's okay. Bases are just other ways to write numbers. Most commonly, people are familiar with things like binary, just using zeros and ones to represent numbers. And so binary is base 2, and so we can only use from 0 to 1 for their instructions. Other good ones, base 8 is a nice one. So you'd only be using 0, 1, 2, 3, 4, 5, 6, up to 7. A common one, if you have ever made a website or anything like that, is hex, where it's actually base 16. That's bigger than 10. So you use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In place of 10, 1, 0 in our system, we write an A, then a B, then a C, then a D, then an E, and then finally an F for 15. Okay. I do encourage you, if you're not familiar with base, to go out, pause the video, go read about it, because it's good stuff. It's good to know that there are other systems for representing our numbers, but that's what 6 here is going to be about. Now let's get back to the question. So, if no base is given, it is understood that a number is written in base 10. This is fairly common. This is the one that we all are used to. Okay. Thus, 1, 1, 2 with a little 3, so we're writing in base 3, is equal to, and see, this is why I stopped and I sort of said, go take a look somewhere else for base, and you might have, if this is your first time reading about base, you might have a bit of a problem, because they sort of, this 3 squared, it's not entirely obvious why, in their definition, why 3 squared and then 3 and then 1. It comes from the fact that when we write any number, in base 10, for example, say 173, that's really 1 times 100 squared, plus 7 times 10 to the 1, plus 3 times 10 to the 0. Okay? And so we replace this with really any base. The hundreds digit is really the b squared's digit, and then the b to the 1, and then the b to the 0. And if you were to keep going, you'd have a b cubed's digit. So that's what's going on, and it's not entirely clear from their definition in this question. So I would say you probably had to be kind of familiar with base or be very good at picking this stuff up. Okay. But 1, 1, 2, the first one goes here with the 3 squared, and then the next one, and then the 2. You sort of work from the units digit to the left. So when we see 1036 with a little base 7, we start with the 6. It's 6 times 7 to the 0, plus 3 times 7 to the 1, plus 0 times 7 to the 2, plus 1 times 7 to the 3. Okay? So that's the idea, and you get 370 there. All right, A part. In what base B is 213 little b equal to 58? So 58 here, we have no little base, so it's 58 base 10. So the numbers we're familiar with. Okay? So we can set up an equation. It's going to be quadratic, and we can solve for b. So 58 is 213 with the b there. So this is going to be 2b squared plus 1b to the 1 plus 3b to the 0. Now, a faster way of writing that is 2b squared. No one really writes b to the 1, and no one really multiplies by 1. And then b to the 0, anything to the 0 is 1, so we get plus 3 here. Okay, so we could quickly rearrange this, and we could get 0, 2b squared, plus b minus, we bring the 58 over, we get 55. Okay. Well, really, I think the only thing to do is quadratic. Well, maybe, let's think about this for a second. What do we need to have? It's a little harder to factor. Certainly I'm having trouble remembering. What do you do with when a is not 1? As I recall, you divide both of these by, or multiply by them. But I'm just going to default and say, by the quadratic formula, and we can solve for b. And we'll probably get a negative b and a positive b, and one of those will go away. B is going to be, okay, negative 1 plus or minus square root of 1 squared minus 4ac. Well, 4 times 2 is 8. And then the minus and this minus will cancel out, so it'll be plus 8 times 55. Well, I don't get to use my calculator. So I could either say, well, this is 5 times 11. 5 times 8 is 40, so 40 times 11. And we'll get 440. Or if I needed to, I could just multiply out like this. Either way. And then this is all going to be over 2a, so this will be over 2 times 2, which is 4. Okay, so we'll get negative 1 plus or minus square root of 441. Now this is a number we should be familiar with. So we're going to get square root of 441 is 21. Okay, and all over 4. So we can either have b is negative 22 over 4. That's not going to work. Or 20 over 4, which is 5. And obviously this one here is ridiculous. Okay. So b is equal to 5. If you wanted to, you could even double check that. 2 times 25, 5 squared is 25. 2 times 25 is 50, plus another 5 is 55, plus another 3 is 58. So that really does work. Okay. So that's a part. Not too bad. Not too bad. Did rely on us understanding what base is. All right, B. Evaluate the following expression. Report your answer in base 10. Wow. Wow, wow, wow. Okay. So, just like with the regular sort of order operations, we're going to focus on what's inside the brackets. And inside the big brackets is some more brackets. So we're actually going to work from this 11 base 2, and then 21 base whatever that is, and 12 base whatever that is, and work out what we've actually got, step by step by step. And this might take us a little bit. So, first, notice that 11 base 2, well, that's just 1 times 2 to the 1 plus 1 times 2 to the 0. That's just 1 times 2 plus 1. That's just going to be 3. Okay, so we've got 3 down there. Now we're looking at 21 with a little 3. With a little 3, well, that's 2 times 3 to the 1 plus 1 times 3 to the 0, just based on our definition of base. 2 times 3 plus 1, 7. So next we've got a base of 7. We've resolved what's going on there. 1, 2, base 7. This is 1 times 7 to the 1 plus 2 times 7 to the 0. Getting great exercise from our knowledge of bases. 7 plus 2, 9. Okay, well now we've got a base of 9 working out. 2, 2, base 9. So that'll be 2 times 9 to the 1 plus 2 times 9 to the 0. 2 times 9 plus 2, 20. Okay, we're running out of room, so we're going to go over to the next page, but I think now we're 2012 base 20. I'll just go back and double check that really quickly. Yep, 2012, base 20. So that's going to be 2, 20 cubed, plus 0 times 20 squared, plus 1 times 20 to the 1, plus 2 times 20 to the 0. So that's 2 times, and it might take you a moment, but this guy here, he's 8,000. Plus, I don't care what this is, it's 0. 0 times anything is 0. Plus 1 times 20 to the 1, well, that's just 20. Plus 2 times 20 to the 0, that's 2. So we get 16,000. Oh, one too many zeros there. Plus 0, plus 20, plus 2. We're going to get 16022. Might give a little statement, thus. Break it all down. I think it was a 1 and a 2. And then it was something that gave us 7 with a 3. So I think that's it. I'm just going to go back and double check. 2, 2, 1, 2, 2, 1, 1, 1. Fantastic. So that's 16,022. We've got ourselves a final answer. I like it. I'm happy with it. And that's question number 6. That's all it is. Just A and B there. So we're going to move on to question number 7. But we're going to handle that in the next video. Thank you guys for watching, and I'll see you next time.